So, why are you in this webinar? Well, even though I can't see or hear you, I do have a good hunch about the reason most of you are very interested in this topic. Because I believe that many of you are currently developing, not on the latest version of Java, which is Java 11, but on Java 8. And to be fair, it's more than just a hunch, because various recent polls show this trend in our community, in our industry. Look, for example, at this poll that JetBrains conducted in 2018, where you can see that about 84% of the people are running Java 8, are developing on top of Java 8. And this was at the time that Java 9 was available. And you see that the adoption percentage of this newer version of Java is pretty low. Now, to be fair, adoption of newer Java versions always goes pretty slow. But we'll see that the world has definitely changed in terms of how Java is released and how Java is developed by Oracle. And this definitely has impact on how we, as developers, will approach this migration path going forward. So JetBrains isn't the only one to do this kind of survey and to look at what's happening in the community. So Java Magazine also did a poll amongst its readers, and there we saw that about 8 in 10 developers, so roughly the same numbers, are using Java SE 8 in production. Interestingly, before this webinar, we also ran a poll on the Pluralsight Twitter account, and what we see there are, yes, indeed, again, Java 8 is at peak adoption with 62%, and the numbers for the other versions are a little bit higher than in the polls of 2018. So things are moving, but things are moving very slowly, because if you think about it, Java 8 was released in 2014, right? And the version before that, Java 7, was a version that was released 4 years before that. So we are used as Java developers to have long stretches of time between major Java releases. But that's not the world that we live in anymore. Because in 2019, we're actually looking at a release schedule that looks quite different for Java. As of Java 9, Oracle started releasing Java every 6 months. So what they did is they stepped away from a feature-based release model where they said, okay, we're going to deliver, for example, lambdas and streams like in Java 8, and we're going to take however long it takes to implement this and to ship this. No, rather they said, we want to be more predictable. We want to have a release train where every 6 months a major version of Java will come out. And we're not setting in stone which features are in there. Whatever's ready is ready and will ship. And what's not ready, well, it can always go on the next release, which is there in 6 months. So this is a pretty big change in the release schedule of Java. So we are currently here. Like I said, Java 11 is the current version of Java. And interestingly is that the Java 11 version is somewhat more special than the other versions that you see in this picture. Because Oracle also realized that if we're going to deliver a new major Java version every 6 months, well, probably not everyone will be able to jump on and to adopt every one of these versions. So what they did is they looked at some of the models that are in other open source projects as well, where, for example, Ubuntu does long-term support releases, where some of the versions that they release are marked as long-term support. And Java 11 is one of these long-term support releases, where at least Oracle, as a vendor, says we're going to support this for a minimum of 3 years, probably much longer, like they did with Java 8 and Java 7. But Java 11 is one of the versions where Oracle, as a vendor, but the whole Java community actually is converging as the next big version after Java 8. So this is some of the context of what's happening in the world of Java itself. I'm going to scare you a little bit, because most of you are on Java 8, and Oracle has actually this month stopped their public updates for Java 8. And this is pretty bad in the sense that there will be no more public and freely available security patches for Oracle's Java 8. And this, of course, means that if you're currently running Oracle's Java 8 in production, you need to do something about that, because otherwise you will be running unsupported and unpatched software in a couple of months. So that's obviously a pretty bad situation to be in. And of course, this doesn't mean that you directly need to jump to, for example, Java 11. But you do need to make a change, because Oracle makes it perfectly clear, also in their frequently asked questions, which you can find at this bit.ly URL, that they intend to make these critical patch updates only available for paying customers. as of this month for Java 8. Now, the distinction that you should make here is that this applies to the Oracle JDK. So that is the JDK that Oracle builds and ships. Now, to be fair, this is the JDK that most of us are using currently in development and production because it was simply the most widely used distribution of Java, and it was free to use both in development and in production. That era ends this month. So Oracle JDK 8 is not an open source build in the sense that it does have a proprietary license, the binary code license. So if you want to stick with Oracle JDK 8, even though the public updates have stopped by now, you can do so, but you'll have to pay Oracle for that. So if you want to stick with Java 8 beyond this month, then you can either start paying Oracle and stay on Oracle JDK 8 and get updates for several more years to come. The other alternative that you have is that you are going to switch to another build of Java. Because Java, in the end, the platform is open source and is developed in a project called OpenJDK. So OpenJDK is Java, and Oracle JDK is built on top of OpenJDK, but they're not equivalent if we're looking at Oracle JDK 8 and OpenJDK 8. What this means is that there are several enhancements and proprietary features that are added on to Oracle JDK that are not available in OpenJDK. So if you're going to migrate from Oracle JDK to OpenJDK, this might be something that you run into. The good news is that there are several open source vendors that have distributions of OpenJDK 8 that they do intend to support for a long time and even for free. So some of these vendors are listed here. Amazon is one of the most recent ones with their Amazon Corrado project, which is the same distribution that Amazon uses within AWS for Java 8. They're shipping this as an OpenJDK distribution that we can freely use and that Amazon will support for many years to come. And the same goes for Adopt OpenJDK and Red Hat's OpenJDK. So you do have several options here. But if you're on Oracle JDK 8 and you're moving to one of the OpenJDK 8 distributions, keep in mind there will be some differences between these JDKs. But the big question, of course, is if you're going to migrate anyway, and if you need to do something right now, do you really want to stick with Java 8? Because a lot has happened since Java 8, and we're now in the world of Java 11. So again, if you're currently on Oracle JDK 8, you also have the option of going to Oracle's JDK 11. Again, this is something that will not be free. Oracle's JDK 11 will be available through a subscription with Oracle. And this means that you get support and updates for many years. Like I said, Oracle intends to use Java 11 as a long-term support version. But the nice thing is that with JDK 11, Oracle has ensured that there is feature parity between OpenJDK and Oracle JDK. So whereas with JDK 8 there were some significant differences still between Oracle JDK and OpenJDK, this is no longer the case with JDK 11. So you can easily move between OpenJDK distributions and Oracle's JDK, depending on whether you want support and you want to pay, for example, Oracle for this. And the nice thing is that, same as with OpenJDK 8, the same vendors that I mentioned earlier, like Amazon and Red Hat and Adopt OpenJDK, will also offer builds for Java 11, for OpenJDK 11, that will be long-term supported. So this means that OpenJDK 11, through one of these vendors or through Oracle, is one of the best targets currently for you to move to if you want to move beyond Java 8. That being said, now some other APIs have been removed in Java 11, and they're not previously encapsulated APIs. No, these were public APIs, JAXB, JAXWS, JAXWS annotations. Only these were all enterprise APIs, but they were part of the Java standard platform, which is strange when you think about it, but it's sort of a historical accident. But as of Java 11, this historical accident has been corrected, and these APIs are no longer there in the JDK. So if your application or the dependencies in your application depend on this being there in the JDK, then it won't run out of the box on Java 11. Of course, what you can do is now add these technologies as an external library to your class path. And these are now all maintained by Java EE, which is now known as Jakarta EE. So you'll have to, if you have these dependencies, you have to add these. And we'll see this in the demo as well. So some of these technologies are very popular, right? Like JXB, XML binding. For some, there's no love lost, like with Corba. But in the end, all of these enterprise APIs are now gone from JDK. And if you're using them, you'll either need to add them to your class path yourself, or maybe you're running on a Java EE application server, and this application will provide these APIs for you. So there's no problem there either. So that's a lot to take in. And what I want to do is I want to do a short demo of a single piece of code that exhibits a lot of these issues that we talked about. So I'm going to move to a editor here. I'm just going to use the Java compiler directly. I'm going to use only this class, this simple class, which contains several issues. Because as you can see, for example, here we're using this Sun Security Util Security Constants class. And we're also using something called data type converter, which comes from the Java XML bind package, which is one of these enterprise APIs. And what I'm also doing here, which is the third problem in this code, is that I'm invoking a method on print stream called newline, which is a private method. So I'm hacking into this using the setAccessible method on this reflection object. Then I'm going to invoke this. As we can see, this will also become an issue when you move to the modular JDK, where things are truly encapsulated. So just to show you that I'm currently going to compile this using Java 8, I'm showing the version here. And what I want to do is I'm going to compile this source file, migration demo, and then I'm directly going to run it as well. There we go. And as you can see, the application runs successfully because we see our string being printed to the console, but there was a warning, just a single warning during compilation where it says, okay, security constants is an internal and proprietary API. But you know, we all ignore warnings every day, right? So as far as we are concerned, this just works on Java 8. So what happens if we are going to switch to Java 11? And we're going to do this using a little trick here. I can now show you that I'm on Java 11, and I'm going to run the same code. So I'm not going to recompile it yet. I'm just going to run it on Java 11. So it was compiled on Java 8, and we're going to run it on Java 11. As you can see, this leads to an exception, which is rare, right? Because Java has always been very big on backwards compatibility. Now, this no class of found error refers to this data type converter class that we're using, which is part of JXB. And we saw JXB has been removed from the JDK. So what can we do? Well, we can work around this by adding a JXB implementation to our class path ourselves. So I can run this application by setting the class path to lib/JXB API.jar to the current directory, and I'm going to run this migration demo class. And as you can see, it now runs because we get the same hello pluralsight string. Only there's a big, huge warning here as well, emitted by the JVM, which again is rare because this logging doesn't come from our code or any of the dependencies that we're using. This logging comes from the JVM itself, and it says an illegal reflective access operation has occurred. And this refers to what's happening here with our hacking into this newline method on print stream, which is a private method. And we shouldn't actually do this. So this is a part of the strong encapsulation of the JDK in action. I say a part because it's only a warning yet. It's not an error. If we're doing this from modular code, then the rules are much stricter already, and we can't really do this. Because we're still in the old class path situation, the code still runs, but there's this big warning, and it shows us that we're doing something that we really shouldn't be doing. So there are some command line flags to suppress this warning, but in the end, the best course of action is to not do things like this anymore and to only use public API rather than hacking into private APIs. Now, typically, our own code bases don't have that many of these instances of hacking into private JDK APIs, but many libraries might have. And if you encounter this, then definitely report this to library maintainers. And many libraries, since the release of Java 9, have already been updated to not do this anymore, and to actually start using public API rather than private APIs. But now you know, if you see one of these warnings, what's happening and what the problem is. Now, so far I compiled the code on Java 8 and I just started to run it on Java 11, and I had to add the JAXB API for that to work. And we still had this warning. But what if we wanted to compile this code on Java 11 as well? And it turns out, if we do that, the warning that we saw before about the security constants being an internal API that we had when compiling on Java 8 has actually turned into an error at compile time in Java 11. So this means that even though we could compile this code with Java 8 and using these internal APIs, we can't do that anymore on Java 11, which means that we can't, in our own code, introduce new legacy that depends on internal APIs, which is totally fair, but it does mean if you do have some of these dependencies on internal APIs in your code bases, then you'll need to update those, and you'll need to use these public APIs. So you might be wondering, okay, so what are these public APIs? How do you find out about this? Because, well, there's now a compile error, but it doesn't really say me how to fix this. For that, you can use a tool called JDAPS. The JDAPS looks at dependencies inside of classes and inside of jar files. And if you pass it the JDK internals flag, you can actually get some advice on how to migrate your application, your code to newer versions of Java. So if we run this on this class file that was compiled using Java 8, it will tell us, okay, this JDK internal API that you're using, don't do that, but use the suggested replacement. For example, an appropriate subclass of the Java Security Permission API, which is in a public package, public API. So JDAPS is the tool that you should use here. Now, one more thing that I want to mention is that we saw this warning when running this code on Java 11. In the end, what you want to strive for is to be able to run your application on Java 11 using the flag illegal access is denied. So by default, it only warns us for these illegal accesses. But in the case of running old code on a new version of Java, we want to be able to run it with this flag enabled, because it means that our application isn't actually using any of the illegal access paths anymore. So it's ready for the future versions beyond Java 11, where maybe the rules will be tightened, and where also on the class path you won't be able to actually do this anymore. So I'm not actually sure why the migration demo cannot be found now. Because it's not in the class path. At the current directory, there we go. And then you can see that the warning that we had before in Java 11 is now actually turned into a runtime error, which seems worse, but of course the premise here is that we fix this, that we start using public API, and that we prevent regressions by enabling this illegal access is denied flag. So this is a small class, but it exhibits many of the common issues that you might run into with your own code, or maybe with dependencies that you're using when moving to Java 11. So just to look back, if you want to migrate from Java 8 to Java 11, then first and foremost, make sure that you upgrade your tooling, your IDEs, your build tools and plugins, etc., because they've all been updated to work with Java 11. Also make sure that you upgrade your libraries as much as possible, because there as well people have been very busy to rip out the dependencies on JDK internals and to only use public APIs. Then also make sure that you use a tool like JDAPS on your own code base to find out if you have any of these dependencies on internals in the JDK, or maybe dependencies on enterprise APIs that have been removed, so you know which dependencies to add when you move to Java 11. And your goal should be to run on Java 11 on the class path there with this illegal access level set to deny. So you know that your code and your dependencies are not actually dependent anymore on JDK internals, because in a future version of Java, the warning that you now get may turn into an error anyway. So better be ahead of that and run with this flag enabled yourself. Then, of course, if you can actually run your code base on Java 11, make sure that you can also compile it, because then you'll be able to start making use of the new features that we talked about. So yes, it's not trivial to move from Java 8 to Java 11. On the other hand, because lots of libraries and tools are already caught up, if you do upgrade your libraries and tools, it may not be as hard as you imagine when you are hearing this and thinking about it. But anyway, this is the path to get from Java 8 to Java 11. So quickly back to this Java release schedule, because, well, we saw that we get a Java version every 6 months now, which is quite a change from the old days where we had big feature releases every 3 or 4 years. So this does mean that you, as a development team, as a company, need to start thinking about, am I going to adopt all of these releases, or am I going to move from LTS to LTS? And while the latter may sound safe, because it means that you can move from Java 8 to 11 and then from 11 to 17, because they're going to designate a LTS version every 3 years, so Java 17 will be the next one after Java 11. It does mean that there will be quite a big gap between these LTS versions, because in between those versions there are still releases like Java 12, 13, 14 and so on that are coming up. And these will be smaller and incremental, so if you actually try to keep up with them, it might not be as hard as you think. And it will prevent you from doing a big bang again, like you're doing now from 8 to 11, and then from 11 to 17. It should also be noted that these LTS, non-LTS releases that are in between LTS releases are not some just experimental releases. No, they go through the same rigorous release process and testing and QA. They have new language features. They have everything that you would expect from major Java releases. So they're smaller, but they're not experimental, and they're definitely not something to be ignored, at least from a point of view of keeping up with Java. Now, there can even be deprecations and removals. For example, you could have some API being deprecated in Java 12 and being removed in Java 14. And you would only find out in Java 17 if you move from LTS to LTS. So there are certain dangers to this strategy as well. And a nice middle ground might be to keep tracking the new major Java releases in your build system, in your testing environments, and maybe not in production, but at least if you use them in your build systems, then you will be able to spot these changes when they happen and not several years after the fact. Now this brings us to the end of what I wanted to share with you all. So just a quick recap. We saw that now, even more importantly, since Oracle JDK 8 is out of free support, it's even more important to start thinking about what kind of JDK you're going to use. By default, people just gravitated towards the Oracle JDK, but this one will be commercial now, so you need to pay for that. And there are many vendors jumping into this field with their own, like Amazon, like I said, Red Hat, and any other JDK vendors. Definitely something you need to catch up on when you move from 8 to 11 are all the new features. We saw a little taste of that in the webinar, but there's much more to explore there. If you've done that, you're ready to migrate your apps to Java 11, and we saw some of the challenges that you might encounter when doing that in the demo that we did. And in the end, it's all about planning the future. So will you be going from LTS to LTS? Will you be tracking the intermediate non-LTS releases? Or will you maybe only do that in your development stack and not in your production? Lots of choices there, but definitely something to start thinking about today. Now, I wanted to share with you some resources. There's a pretty large but pretty important document as well called Java is Still Free, created by the Java champions, of which I'm part, which can be found at the bit.ly Java Still Free URL shown here. And of course, if you're on the Pluralsight platform, I really highly recommend you check out the What's New in Java courses. There's one for 9, 10, 11, and I'm currently working on one for 12 as well, because it will be released in March this year. And one of the biggest features, like I said, was the module system in Java, which is covered in the Java 9 Modularity First Look course.